participants, delegates. First of all, I would like to express my gratitude to the presence of CSDY and all members of the organizing committee for making this conference a big success. It is also a thanks to all who have behind the success of this work and giving us a platform for presenting our research work and interacting with each other. The research topic I'm going to present is entitled Phase Changes and Photocatalytic Activity of BIMNVOX series for degradation of crystal violet in aqueous media under visible light. This work is authored by Ahlam Al-Alas, Niazi E.S. Al-Aliki, who is me, and Raya Fahid Al-Ansi, and it belongs to Department of Chemistry, Taiz University, Department of Pharmacy, Aside University, Yemen Standardization Meteorology Quality Control Organization. Actually, dye pollutant released with industrial water, an important source of environment concern. Crystal violet is a member of trimethyl family of dyes that has several industrial and biological applications. This large family of dyes has extensively variety of industrial process, but many are known also to have cancerogenic and mutagenic properties. Advanced oxidation processes have been purposed to widely investigated for photocatalytic degradation in industrial wastewater. Semiconductors-based photocatalysis have been found to potentially advantageous as it costs less money and doesn't create secondary contamination. Among known semiconductor photocatalysis, titanium dioxide has been extensively studied for photocatalytic and photochemical application because of its thermal stability, precise surfaces, low cost, and low toxicity. However, because of its relatively high band gap, titanium dioxide is activated only by irradiation in UV visible light lesion, with wavelengths shorter than 387, which severely limits its commercial application for water and wastewater treatment. Hence, many researchers have been devoted to find, design, and optimized efficient semiconductors photocatalyzed with maximum absorption threshold that effectively accelerate the photocatalytic degradation for organic dyes when irradiated in the visible light region. Recently, the layer perovskite type bismuth oxide and its metal dot lead and not designated as BIMNVOX belonging to Aqueous family have attracted a considerable attention due to its remarkable non-band gap with a potential visible light potential efficiency. In this work, we report a new member of the BIMNVOX family named BIMNVOX, used for photocatalytic degradation of crystal violet dye. This study was devoted to carefully investigate the influence of metal dot during phase stability and photocatalytic properties of bismuth manganese tandate oxide under visible light irradiation. The photocatalysts were prepared by using solid-state reaction by mixing these three oxides as shown in its molar ratio, heated at 650 degrees Celsius for 20 hours. Many techniques have been employed for characterization of photocatalyst. X-ray powder diffraction pattern were collected on Philips BW1050/30 X-ray diffractometer using copper K alpha radiation. The unit cell parameters were refined using powder X software program. The average crystalline size was calculated from the diffraction line plotting via the Shearer equation. Differential thermal analysis thermogram were collected on Perkin-Elmer thermal analyzer. The optical band gap energy for photocatalysts were estimated from UV visible absorption spectra collected on Shimazu UV visible spectrophotometer. The direct band gap energy was computed from the absorption edge using the following formula. Surface area measurements were performed by nitrogen absorption distortion isotherm at 77 Kelvin on Autozor 1 quantichrome absorption apparatus. The photocatalytic measurements were performed using 25 milli aqueous solution of crystal violet dye with concentration 5 times 10 to the power minus 4 molar, while when adjusted at pH 10 using a dilute solution of ammonia and sulfuric acid. This solution was placed in a photoreactor with capacity 415 ml with magnetic stirrer. Before catalytic reaction, 2 milligrams powder sample of photocatalyst was dispersed in aqueous media. The resultant suspension was then magnetically stirred in the dark for 25 minutes, for which the solution dissolvation equilibrium. Visible light with wavelengths greater than 400 nanometers using 300 watt xenon lamp was irradiated perpendicularly to surface of the solution a fixed distance of 25 centimeters between the physical source and the surface of the solution. At a specific time of 10 minutes, about 5 ml coat of the reaction mixture was withdrawn and filtered to separate the catalyst sheet. Concentration of dye, various irradiation time were recorded and measured using a maximum absorption using Shimazu UV visible spectrophotometer. The photocatalytic activity of the catalyst as a fractional composition for dye degradation was investigated using a pseudo-first order kinetic model. Powder of the sample were first analyzed by XRD pattern, as we see. It is interesting to note that the diffraction pattern for 0.15 seems to be identical to the parent compound 0.4, and this is clear evidence that there is no change in the crystallographic structure with increasing the dopant concentration up to this limit of concentration. However, the appearance of the two sublatics peaks are shown or indexed as 0.20 and 200 at around 32, and a single sublatic peaks appear at 46, indexed as 020, are clear evidence for stabilization of beta phase of orthorhombic symmetry. In addition, with increasing the amount of the manganese content in the BIMNVOX, it can be shown that the stabilization of gamma phase with tetrachlorosymmetry occurs with composition 0.13 as evident in the appearance of the distance, the small subatomic peaks indexed as 110. Here we can summarize the results of the crystallographic refinements along with the surface area measurements of the photocatalyst. As we can see, there is a sudden increase with the sub-lattice parameters with increasing the concentration of manganese. This can also be reflected by the increasing the XRD crystallographic density as well as the average crystalline size. This trend can be attributed to the large overall expansion of the lattice with increasing the total concentration due to the substitution of manganese of small ionic ledgers in the medium size of large, small reactors. However, the BT surface area remain unchanged, as we see. The range from 0.19 to 0.24, indicating there is no change in the macroscopic level with increasing dopant of manganese. The XRD results can also be confirmed by using the differential thermal analysis. As you can see, the DTA thermogram for the balanced compound and the composition with the point of 5 show two endothermic peaks, which are characteristics to the successive transition from alpha to beta to gamma, while the single endothermic peaks shown at the